Okay, so we're moving a little bit fast here. There's no more interactive stuff for the rest of the tutorial, but we're going to talk a little bit about on-premise FPGAs and then actually have a live demo that you guys can mess with and potentially break. So tutorial roadmap, we talked a little bit about on-premise, or sorry, AWS FPGAs setups with FireSim, but now let's actually go into local FPGA setups. So we'll talk a little bit about how to actually run things locally with your own FPGA. Hint, hint, there's not going to be too much that we're actually going to change. And then we'll talk a little bit about how we actually architected the FireSim manager to deal with this. So we get a lot of questions on, can we run things locally? And the answer is now, yes, we actually can. So we now have support for on-premise FPGAs, specifically Alveo U250s. We're not barred to just using U250s. We can actually expand to other FPGAs. We just don't have FPGAs, other FPGAs at Berkeley. We care more about the U250s. But you can go ahead and try your own out. And the nice thing is that it seamlessly integrates with all of the FireSim collateral and tooling that we talked about. Chipyard, FireMarshal, FireSim stuff. So let's actually talk a little bit about how do we actually build and run the simulations locally so that we can actually run things locally. So building a bitstream. So you should remember this. This is basically kind of the build recipe that you saw earlier. And really you're only changing a couple things. In this case, I changed the target config. You don't necessarily need to do that. But the platform config is now changed to the base Vitis config. AKA, I'm just saying to the Golden Gate compiler, I'm now targeting a Vitis FPGA. Then at the bottom for the bit builder recipe, I changed it also to be Vitis as well, indicating, hey, I'm going to use Vitis, which is the local FPGA synthesis tool. So pretty quick and easy there. Now, from the build perspective, so if I look at that config build YAML file, how does it differ from before? So in this case, I want to build locally. Not necessarily always has to be the case, but in this case, we're assuming we're running on a desktop machine where the FPGA is connected and I only want to run on the desktop. I can now change the build farm to be what's called externally provisioned. I'll mention what that is in a second here. And I basically specify localhost, aka I want to build locally only. I want to build on the machine itself. And then, of course, I change the builds to run thing to say, hey, I want to run that particular recipe that I made earlier. So a lot of it is the same. The main area that you're changing here is the build farm. Then you're going to type in build bitstream. However many hours later, you're going to get a result that looks like this. It's going to look very similar. There's going to be something in this deploy triplet override space. You can basically ignore that for right now. That'll be auto-populated for you properly. And then you'll have an XCL bin, which is the Vitis way of indicating what a bitstream is. So that'll be an actual file. And the nice thing is that with FireSim support, if you upload that file to something like a public S3 bucket, or you put it on your website or something, others can then point to that file as a URI or a URL and automatically download it, and FireSim will download it and run it itself. So it allows you to share bit streams, kind of like what we did with the AWS. Now, running it, again, kind of just going through the configuration files here, is very similar as well. So at the top here, you can see that for the run farm, we change a couple things. We say externally provisioned again. I'll go into that in a second here. I basically indicate that I'm running on a Vitis particular machine. That's what this deploy manager is. And then I specify that I'm running localhost again. So the keyword here is that it says run farm host to use localhost. Then for the target config, it's the same thing as before. No net config, no net num nodes. In this case, I just set it to 1 just to be sure. I point to the hardware config that has the XCL bin, aka the bitstream. I change the workload name and everything else is the same. Then I can do FireSim launch run farm, FireSim infra setup, FireSim run workload, FireSim terminate run farm. All the same things. Now, very quickly, let's talk about what's happening behind the scenes here. So the manager itself, or that FireSim command, was basically re-architected to allow you to do arbitrary clusters. So without too much of the details here, feel free to talk to me afterwards. Basically, you can support AWS setups where you spawn out builds to build farms and spawn out to arbitrary FPGA simulation machines. In the case where you're doing everything locally on a single machine, you can have the build and the run farm be the local host, aka that only machine that you have. You can also change it up and you can have a custom run farm. So if you have multiple machines that have your own FPGAs, you can also set that up as well and still build locally. You can also do any sort of combination of them. And that's basically what these sections are in the config, build, and runtime. They're basically specifying what the cluster that you're targeting looks like. Does it have FPGAs on it? How many simulations can it support? Things of that sort. So that's what this is saying. We basically have one for AWS EC2 and then one for what we call externally provisioned, which basically means that your cluster is specified as a bunch of IP addresses. But if you are willing to change it up, you can actually target different platforms or different types of cluster managers. So if you have your own like vsub command to like spawn out different simulation machines, you can add that in very easily into the system. And then we also need to actually talk about, what's the type of FPGA that's used. In the past, I just talked about, okay, it has an FPGA potentially, and it can run a certain amount of simulations. We also have abstractions out to target different types of FPGAs. That's what's called bit builders and deploy managers, aka bit builders is how you're actually running Vivado or whatever your synthesis tool is. And then you actually have your deploy managers, which indicates, okay, how do I actually flash the FPGA and run the simulation on that particular type of FPGA? Again, similar hooks and abstractions for that. So a complicated matrix of stuff where you can do things on AWS with IP addresses, or you can do things locally. Basically, there's a ton of configuration here that we don't have time to get into. Now, the nice thing here is we talked a little bit about metasimulations, and we said, okay, what happens if things start to break, right? So Sagar didn't go into this recap of metasimulations, but basically, sometimes you want to run software RTL simulation of your FireSim simulation, aka I want to match the same performance that I see on the FPGA, but just in software RTL simulation. So the nice thing is that in the past, what you would do to run this is basically type in the make command, and you would basically add your binary that you want to run, very similar to what you would do in Chipyard, and that's kind of annoying. However, we basically allowed the FireSim manager to basically spawn up these software simulations and arbitrarily use the same infrastructure that was used before. So if you look inside of the config runtime file, there's this metasimulation area. And basically, if you set it to true, instead of spawning FPGA instances, it'll basically use those simulation instances and actually distribute software RTL simulations to them. So it's very much kind of just like distributing software RTL simulation arbitrarily. So if you have a large run farm with a lot of machines running, whether it's a cluster that you own yourself or on AWS, you can basically spawn simulations across all those machines in parallel. But this is software RTL simulation. So you now are able to actually dump full fidelity waveforms and do whatever you want in software RTL simulation. It's just now managed by FireSim. And it still has all the same capabilities as before, copying over the workload, results, spawning the simulations, and copy things back nicely. So long story short, you basically have a full workflow where you're able to work locally in Chipyard on some simple things. You can debug with Chipyard, and then you can actually scale with FireSim to working both on FPGAs and distributing out software RTL simulations on multiple machines. So with that, since I'm low on time, basically, we'll run the demo, and basically people can start doing things with the demo, but we'll move to the conclusion, then people can come and interact with the demo themselves. But to give a quick primer here, so this exists. We're not just faking it. So drum roll, whatever the case is, that was a horrible drum roll. We basically have a machine that's called FireStation underneath the table here that Sagar is going to raise very slowly and carefully. That is basically our local FPGA machine. So this entire time, it has been running FPGA simulations of images running ResNet or bare metal. Okay, made it up. And it basically, there's a bunch of specs. They're all commodity specs with a local FPGA. As you can tell, it matches the FireSim logo color. And it's relatively cheap with respect to running things on AWS. So again, the costly part here is the FPGA and getting access to the FPGA, but you can actually get them donated. So we're actually running on this machine a ResNet workload that's running on the Gemini DNN accelerator inside of a Rocket-based SoC. And then we're actually simulating it on FireSim on this desktop locally. So there's no access to the internet except for getting an image, which is where you all come in. So long story short, you all will be able to submit pictures from the internet, any picture, and have it be predicted by ResNet, simulated faithfully on FireSim. So there's a lifetime of the demo, but basically the image gets copied from a Google form, runs through FireSim and Gemini. Again, happy to go into more detail afterwards. But the important part here is that on this screen here, I'll turn it around so that people will be able to see, you'll be able to see what the prediction is for the image that was uploaded. So for this case, if you want to, you're welcome to go to this link, demo submit, and go ahead and input any image URL from anywhere on the internet, as long as it's publicly accessible, and it will predict it. I will send it here to this machine. It will predict it and give an output result. So it has to do it serially when we have one FPGA, but you can see what gets predicted. Caveat here, everything is public, so if you be careful with the pictures that you upload. ResNet, you know, while it's good, it's still sometimes off. So with
just show the Slack up here.
The Slack is not on this computer right now, so we'll have to do it later. Yeah, so we'll do it later, but there's plenty of images here. If you want to come up after the presentation, we can talk about it and you can look at some photos and see what comes up. So yeah, so very quickly went through on-premise FPGA support. So we were able to kind of set this up in under an hour, 40 minutes, and this was like the first time we ever set up on-premise FPGA support. So very, very quickly set up, and the flow is a lot easier now because we have very good documentation on it. And all the features that you see on AWS basically apply to the local setup as well. So with that, please refer to our documentation. We have a lot more documentation about these clusters that you can spawn up individually, the local FPGA setup, and much, much more. But I'll refer you to that.